Hello, everyone. In this two-part video series, we will explore the dynamic and powerful nature of tropical cyclones, unraveling how they form, move, and impact our world. In Part 1, we will delve into the conditions that lead to the development of tropical cyclones and how they gather strength from their environment. Let's begin. Just imagine. Take a look at the sky out there, and you see this. What is happening? In year 2008, the skies over Cyclones witnessed this special scene. This is the eye of Typhoon Nuri, an area with calm weather at the center of a storm. It's a rare moment that captures an important structure within a tropical cyclone. This tropical cyclone is in its weakening process when passing over Hong Kong, so the eye is diminishing. However, it can still be observed by members of the public in Hong Kong. Typhoons are what we commonly call them. However, precisely, the names of such weather systems are tropical cyclones, and typhoons are one of the intensities of tropical cyclones. I believe you can still remember what happened in these images. They are storm surges happening in 2018, when Super Typhoon Mangkhut attacked Hong Kong. We will delve into the heart of these natural giants. From their birth over warm tropical waters to their eventual dissipation, we will explore the life cycle of tropical cyclones and the evolving science that allows us to forecast their paths. How do tropical cyclones form and grow? How can we predict them? Let's take on a journey into the eye of the storm as we unravel the mysteries of tropical cyclones and the science behind forecasting their paths. A tropical cyclone is a storm system with very low pressure at its heart, known as the eye, where pressures are usually under 990 hectopascals. Sometimes, the pressure can drop to extreme lows, like the 870 hectopascals recorded in tropical cyclone Tip back in 1979, the lowest ever measured in a tropical cyclone. These cyclones form when warm air rises and cooler air rushes in to take its place. The spinning of the Earth then makes the incoming air swirl, creating the tropical cyclone. Such storms can have winds that reach speeds of more than 250 km per hour and can span up to 2,000 km in width. In the center of a tropical cyclone, air moves downward. This center, or eye, is a zone of calm with no clouds and gentle winds. The eye is encircled by the eye wall, an area with the fastest winds and the heaviest rain of the storm. Beyond the eye wall lies the vortex, where air shoots up quickly and pulls in more air from the surrounding area, leading to the formation of huge clouds. When this part of the storm, the vortex, moves over Hong Kong, it usually brings strong winds with it. However, if the eye of the storm passes over Hong Kong, there can be a huge drop in wind speed. The Earth is a rotating globe. Within this rotating Earth, the warm surface of the ocean is located in the tropics. As the sun is shining over the ocean, the warm surface of the ocean makes the hot, wet air lift. The water will be energized by the sunlight as they absorb heat. Steam or mist rises from the ocean surface. This rising creates an area with low pressure in the center. The air around this area moves towards the center because of the low pressure. As this air moves in, it spirals upward, and when it gets higher, it gets cold, turns into water droplets, and forms big storm clouds. In this process, something called latent heat is given off. This released heat gives the storm more power, making it even stronger. When the air gets to the upper part of the lower atmosphere, it spreads out to the sides and comes down around the outside of the tropical cyclone. Then, this air gets sucked back into the center with low pressure, and this cycle keeps happening. As more hot, wet air is pulled in, the tropical cyclone gets larger. Right at the center of the tropical cyclone, the eye, there is cooler air that goes down and warms up. This makes a peaceful, clear spot. The air goes down at both the edge, outside the vortex, and in the center, in the eye of the tropical cyclone. In the northern hemisphere, the air at ground level goes into the cyclone, turns to the left, climbs through a huge circle of clouds, and then, above the storm, it turns to the right and goes outward. When this air turning to the right gets to the edge of the tropical cyclone, it starts to drop and gets warm, leading to clear blue skies. Because of this, the air that goes down in front of a tropical cyclone usually brings really hot, nice weather with only a little wind. At the same time, air is coming together over the eye of the storm, which is why the air goes down in the eye. The air that goes down gets squeezed, making it smaller in volume and warmer. This is why the eye is the hottest part of the storm and has clear skies. A huge amount of energy is needed to form tropical cyclones. This energy has two main sources. The first is the latent heat that comes out when massive amounts of water vapor turn to liquid during evaporation and condensation. The second is the warmth from the ocean water itself. Tropical seas with temperatures above 26.5 degrees Celsius are perfect for creating tropical cyclones because the high heat leads to the evaporation of a lot of water. Different studies mention various minimum temperatures needed for a tropical cyclone to form, between 26 degrees Celsius and 27 degrees Celsius. A tropical cyclone is a kind of storm that spins. In the northern hemisphere, air moves towards the center of these cyclones from the left side. The Coriolis Force, which makes the wind change direction and causes the air to spin, is behind this movement. Since the Coriolis Force doesn't exist at the equator but gets stronger further away from it, most tropical cyclones happen in the tropics, normally from 10° to 20° north and south of the equator. This is where the Coriolis Force is enough, and the water is hot enough to provide the energy and moisture needed for air to move up. Tropical cyclones can be found between 5° and 20° north and south over the tropical oceans, but not too close to the equator, within about 5 degrees, because there the Coriolis Force isn't strong enough. Apart from tropical oceans and suitable latitudes, two other conditions favor the formation of a tropical cyclone. They are weak upper winds and suitable airflow between the upper and lower levels. For weak upper winds, during the development of typhoons, convection occurs. Warm, wet air moves in and provides energy for the typhoon to grow. If the upper winds are strong, they tend to disrupt the organized pattern of convection and disperse the heat. Secondly, for the suitable airflow between the upper and lower levels, typhoons tend to grow bigger if divergence at the upper level is stronger than surface convergence. This is because this set of conditions initiates the upward movement of the air from below. At the same time, air continues to move in at the surface. The divergence at the upper level also helps prevent the convergence flow at lower levels from increasing the air pressure there. The constant flow of energy over the warm sea makes the air rise and create clouds. As more air goes up, the air pressure on the ground gets lower. This makes even more air move into the tropical cyclone, giving it more energy to grow. This creates a cycle that keeps making the tropical cyclone bigger. That's all for part 1. In part 2, we will talk about the track of tropical cyclones, their dissipation, and how we can predict their path and intensity.